Hello everyone, welcome to my channel. So today we are going to do Leetcode bi-weekly challenge. First question means for now first question. Then we will be going ahead with other three questions as well. So let us first read this question, then about the constraint. Then we'll check out that from the example how we can do this question, and then finally the coding part for the same. So let us go ahead. So here, first let us read. So here you are given an array nums of positive integer and an integer k. In one operation, you can remove the last element of the array and add it to your collection and return the minimum number of operation needed to collect elements 1 to k. So basically, we are given with this k, right? And this nums array which is given to us, and we are required to collect all the elements from 1 to k. And for collecting these, and that also from the last. And for collecting these, how many number of operations are required that we need to return. So first, let us check that what is the constraint for the same. So here we can check that the constraint which is there, that is up to 50. So it is like pretty much low, means even n square solution would easily work here. But rather than going with n square solution, let us go ahead with order of n solution, as we can go ahead with that also. So here, what we are required to do means, I'll not first go ahead with what we are required to do. Let us take that here. First, the thing is that we will be picking this element because this is equals to k, right? So this we will be adding up to our collection. And that collection we can take either vector, either map. Map won't be required, but either a set or array, anything. So we will be adding this here. Then this 4 is not required in our collection because it doesn't goes in the range of 1 to k, right? But we are required to step over this element as well, right? So that's why this is one of this is the first operation, this is the second operation required. Then this is the third operation required, and then this is that fourth operation, and we are able to get the elements in a collection from 1 to k. So basically like this, we are here doing 4 operations. And when we go for this array, now here again we are starting from last. So 2 is that element which is required in our collection and we will be going ahead. Then 4 is also that. Then 5 is k is equal to, right? And then this one, that is also part of our collection, and 3 is also part. So basically the whole array which is there, that is a part of our collection, and for getting all of them we are required for 5 operations. And when we go ahead with this, so here at the starting 1, then 3, then 5, not part of collection, but as we know that 1 is there, then 3 is there, but we were totally required 3 elements, means 1 2 3, right? So still we require one more element which lies between 1 and 3, right? So that's why we will be required to do this operation as well. So till now 3 operations, then on 4th operation we are able to get that element also. So that's why here answer is 4. So basically like this we are required to do this question. The thing is that we need to check that have we got all our elements required till now in our collection. Basically all those elements which lie in this range means basically 1 less than equals to k. If we are able to get all the elements in this range, basically the size where we are containing those elements, if that is equals to k, then we can directly return whatever number of operation we have done, that we can return. Else we will be going ahead and doing more operation on the same. So this was that what all we are required to go ahead. Now let us go ahead for the coding part for the same. So here first thing is for a collection, what we will be keeping is either we can keep any unordered map or not map, unordered set or vector. So let us take here unordered set. So as the type is int, so that would be the thing. And now what directly we are required to do is we will be starting our I equals to nums dot size minus 1 and I greater than equal to 0, I minus minus, and then we will be simply checking that if the element which is there is a present element which is there, if it is nums of I is basically greater than or equal to 1 and that nums of I is basically less than or equals to k, then in that context, whatever we have taken for storing our collection, we will be inserting into the same, and here we will be increasing the count. Count basically refers to the number of operations which we are doing here. So at the starting, the count would be 0. And then next, if our s dot size is equals to k, then in that context, we will be returning the count. Else at the end only we'll return our count. So this is a thing, and let us now run. Then it is not working. I just minute. Yeah. Okay. So if we run the code, so here we get, and if we use the example test cases in that context also 454, and here we can check it is 454, and then if we submit the solution, then here it got accepted. So now let us check that what is the time complexity and space complexity for the same. So basically the time complexity for the same is order of n and the space complexity for the same is order of n again. It is just because of the fact because we are using that unordered set for storing. So that's why the time complexity becomes order of n. But the thing is that rather than storing, we can also do one thing that we can simply increment some other counter and then we can check that if that counter is not when that counter becomes equals to k, then we can directly return that count. That also thing we can do means we can go ahead with other solution as well. Like here we can directly use that for the element count. So here rather than inserting here we can simply increment the same, and here we can check that if our element is basically equals to k, then we can return the count. Okay, yeah, basically there it was removing the duplicate, so that's why this solution won't work. That is also one of the things. One minute. So basically earlier what we were using was here unordered set, right? So unordered set was simply removing the duplicates, right? So here the thing is that element will become equals to k in this scenario only. So that's why it won't work fine here. And that's why we can't reduce it here. So that's why we are required to go ahead with previous solution only, and the time complexity and space complexity will remain as it is. So this was all for this particular question. If you have any doubt, you could comment that down. And if you really like this solution, then do like, share, and subscribe to my channel. So yeah, thank you.